In this first problem, there is no greatest common factor between the two terms, so the next step I would take is to look for a pattern. There is a pattern for both terms are perfect squares, so the difference of two squares method will be used to solve this equation. Looking at 36, its square root is 6. For m squared, its square root is m, and 11 is the square root for 121. Putting the answer in the form of a plus b and a minus b, the factored equation is 6m plus 11 and 6m minus 11. To solve the factored equation, both terms will be set equal to 0. Using the zero product property, I isolate the m's in both terms, and my final answer, which are the x, would be 11 over 6 and negative 11 over 6. For the second problem, there is also no greatest common factor, nor is there a pattern. So with three terms, I will be factoring by grouping. The first step is to multiply the first and the last terms together. In this case, it would be 1. Now, I have to find the factors of this 1 that will add up to the middle term, which is 2. Luckily, the first set of factors for 1, which is 1 and 1, both adds up to 2 as well as multiplies to 1. I'm going to take these two new factors and replace it with the 2 in the middle, getting this new equation. With 4 terms, I'm going to find the greatest common factor for the first two terms and for the last two terms, which is x and y. Taking these greatest common factors, I'm going to put them in front, then put the remainder of the two terms in parentheses. If the two enclosed terms are the same, it means I am on the right track. They will be the first set of factored terms, and the second set will be the outside variables. With the factored equation, I will set them equal to 0 to find the x of the quadratic equation. Using the zero product property, I found that x in both cases equals negative y.